sometimes it's useful in 3 dimensions to be able to find the length of a vector using the absolute value of the vector. Here we have a situation where we've got to find the length of a vector. Displacement vectors start and finish in space, whereas position vectors always start at the origin. So to get to capital A, we've got to go out position vector A, so we've got to go out 3 in the I direction. We've got to go -2 in the J direction, which is in the Y, so we've got to go out there, so we've got like a little rectangle going down there, and then out 1 in the K direction. So we've got, that is vector A, and that'll be point A. And point A is 3, -2, and 1. Vector B, to get to capital B, we've got to go position vector B, starting at the origin, we've got to go -2 in the I direction, so -2, +3 in the J direction, so that's 1, 2, 3, so we've got to go up there, and then +3, so we've got to come out 3 units, 1, 2, 3, so we've got to come out this way 3 units. So here is vector B. So it'll start at the origin and it'll come out to there. So there's vector B, and the coordinates will be -2, 3, and 3. So the length of the vector we've got to find is this vector here, from there to there. To find vector AB, so it would be useful to find vector AB first. So to find a displacement vector, it is just the second one minus the first one. So it'll be position vector B minus position vector A. Going back to triangulation, you know that A and then plus AB. So we go out A plus AB will give me vector B. So we can actually just transpose that and get AB is equal to B minus A. Or another way to remember it is to get AB is just the second one minus the first one. So vector B is equal to -2i plus 3j plus 3k. And from that, we've got to subtract vector A, which is 3i minus 2j plus 1k, or just plus k. Be very careful with a minus here because we've got to change all these signs. So we get -2i minus 3i, which will be -5i, plus 3i minus -2, minus 2 will be plus 2j, so there'll be plus 5j. And 3k minus 1k will be plus 2k. So that would be the vector starting at A and going all the way up to B. So that's vector AB. So if you like, we could put double arrows on that to show that's a resultant. So vector AB. Now we know that the absolute value of vector B is just the square root of each of these squared. So it'll be -5 squared plus 5 squared plus 2 squared is equal to the square root of 25 plus another 25 plus 4, which will be equal to the square root of 54. So it'll be 7 point something. So that's the length of any vector. Now, if you were just to try and use some sort of geometry and that to be able to work that out, it would take a tremendous amount of work to be able to work that out. But using vectors and the absolute value of a vector in 3 dimensions, and what we know about that, it's quite easy to do. So just bear in mind that there's a difference between position vectors and displacement vectors. Position vectors always start at the origin and go out to an endpoint. Displacement vector, 2 points in 3-dimensional space, one of the points not being the origin. So vector AB starts there and ends there. And then to find a vector, knowing it's two position vectors, it's just the second one minus the first one. So the vector that goes out to this point minus the vector that goes out from the origin to point A. Subtract the two, you get vector AB, and then to find the length of AB, it's just the square root of the individual components.